Subhash ji, Dr. Subhash Goyal, sir, could you please mute yourself?
Of course. Good morning, sir.
Good morning. Good morning, all of you. Very warm welcome uh, to ATAL FDP on structural equation modeling and artificial neural networks in management research. We are extremely lucky, and we are very fortunate in this inaugural session. Uh, we have a very prominent guest who would be the inspiration for the younger generation, and they would be the guiding principles. Their research is their approaches would obviously matter a lot to all of us, because if we will see their profiles and all, we will definitely being motivated a lot. And they are make in India only. They are from India, and they are nurturing the talent across the globe, and they have the potential actually to to give a very good guidance to all of us. Before beginning this session, because somebody will log in and that the things will continue, I will hand over my, this session to my HOD participants. Please, when you are logging, please try to mute yourself first. Okay, so I'm handing this session to my HOD, Syed Nadimul Haq, to please welcome all the guests and proceed the things. And I'm extremely sorry because Dr. Asad Ahmed sir is being appearing as Abdullah's PC, because there is some glitches in the technical glitches. So he will run the session. So HOD sir, could you please start the session?
Thank you, Dr. Jamshed. Respected Chief Guest, Professor Manu K. Vora, Member AICTE NEP 2020 Implementation Plan Committee, Expert Peer Reviewer, AICTE ATAL FDP's 2021-22, Guest of Honor, Honorable Vice Chancellor, GD Goenka University, Professor Tabriz Ahmed, Guest of Honor, Professor Pankaj Sinha, FMS University, Dean SMBS, Jamia Hamdard, Professor Shibu John, Dean Student Welfare, Jamia Hamdard, Professor Reshma Nasreen, my dear colleagues, all the participants from different universities, institutes, very good morning. On behalf of Department of Management, SMBS, Jamia Hamdard, I welcome you all. First of all, I would like to thank our esteemed guests, today's chief guest, Professor Manu K. Vora, Guest of Honor, Honorable Vice Chancellor, Professor Tabriz Ahmed, Guest of Honor, Professor Pankaj Sinha, for sparing their valuable time for this FDP. Thank you very much, all the dignitaries. The Department of Management is committed and always encourage all of its stakeholders to take initiative in various activities like research projects, publication, participation as a resource person in different national and international platforms. We are also providing part-time PhD program for working executive with a view to strengthen our bond with industries. The industry institute interface would consequently give our student latest insights and happening in the globalized economic platform. I would like to congratulate and appreciate the young researcher of our department, Dr. Jamshed and Dr. Asad, for this research initiative. It would definitely help all the participants in their endeavor in the research field and for their quality publication in future. It gives us immense pleasure that our Department of Management, Jamia Hamdard, New Delhi, in collaboration with AICTE Training and Learning, ATAL Academy is organizing this 5 days faculty development program on structural equation modeling and artificial neural network in management research from 13 December to 17 December 2021. The aim of the FDP is to provide participants with advanced insights on the fundamentals of research design and methodology to conduct relevant research that will aid quality decision making and contribute to the body of knowledge in various areas of interest. This advanced FDP aims to provide a platform where the participant can develop analytical skills which would enable them to tackle multitudes of problems in the areas of research and enable the participant to develop research papers which would be published in the journals of high repute. The workshop also aimed to orient the young faculty members with a view for more relevant topics which are vital for the overall growth of the faculty members. I am sure that all 5 days of this FDP would be very interactive and fruitful as several learned resource persons are in the line to their presence in the FDP. I once again welcome all the esteemed guests and participants for this FDP and wish all the very best for the success of this FDP. Thank you very much.
Yeah, thank you very much, Dr. Asad. A very good morning to all of you. Respected Professor Vohra, Professor Tabrez Ahmed, Vice Chancellor, and Professor Pankaj Sinha, Professor Nadimul Haq, HOD Management, and Professor Reshma Nasreen, DSW School of DSW Jamia Hamdard. I welcome all of you once again, and I am very thankful to the Department of Management to conduct this wonderful 5-day FDP program on structural equation model. I just wanted to briefly tell you about Jamia Hamdard and the School of Management. School of Management was initiated in the year 1998. So precisely we are in the 23rd year. And this short span of period, we have reached to around 1,500 students in the School of Management. We are offering 3 different types of MBA programs. We have a BBA program and a BCom programs. There are a lot of students from North India, South India, West, Western part and Eastern part. They come here and we create a kind of a national integrity in the campus. Jamia Hamdard is also not very old university. It's just a 32-year-old university, and with this 32 years, we have achieved a lot of accolades. Jamia Hamdard is one of the best universities in terms of its ranking, whether it is NIRF or NAC accreditation. The only university, I mean, you will be surprised to know that Jamia Hamdard is the only university in Delhi which is going to have its 4th cycle of NAC accreditation, and we have been getting all through NAC A grade accreditation. And School of Management, as I mentioned, is one of the important pillars of the School of in the Jamia Hamdard. Jamia Hamdard has around 11 schools. If you know the profile of Jamia Hamdard is slightly tilted toward the healthcare, university. We have very good medical college, allopathic as well as Unani Medical College. Our pharmacy school is number 1 in the country for last 3 successful years, and this ranking is not from any private ranking. This is by the Government of India, NIRF, and our nursing college is very prominent and very well ranked. Our School of Science, School of Computer Science and Engineering, and School of Science, I mean, they all are ranked very well in terms of their publication, in terms of research activities that we carried out. So I once again congratulate the Department of Management for organizing these kind of programs. Department of Management has always been in the forefront of doing research activities and other type of management other than classroom teaching. So I once again congratulate the Department of Management for successfully doing these kind of programs, and particularly Dr. Asad and Dr. Jamshed for bringing out these kind of research FDP programs. So congratulations to the Department of Management and thank you for inviting me.
Thank you, Asad. Good morning to all of you. Good evening to Dr. Vohra, and good morning to Professor Tabriz Ahmed, Professor Sinha, Dean SMBS, Professor Shibu John, Head of the Department, Sayyid Nadimul Haqsa, and the organizers. Let me extend a warm welcome to all of you on behalf of our Honorable Vice Chancellor as well. In addition to what Professor Shibu John has told about Jamia Hamdard, a thing that we would like to reiterate time and again, and that was the vision of a founder father as well, to skill our students in a way that to increase their employability. Therefore, most of the courses that Jamia Hamdard offers are based towards skilling the minority and marginalized population. As we all know that we cater to a segment of the population which is not that ahead in education. So we cater to the marginalized as well as the minority communities at a very reasonable fees. We try to just focus on the sustainability of the organization with very few margins. We try to skill the and in the process, as the Professor Shibu John has told, our endeavor has been rewarded in terms of a consistent A grade ranking in NAC. We are aspiring for the fourth cycle A plus now, and hopefully this year, next year, hopefully we'll be getting that position. We have, in line with the new education policy, we have also started a Moradabad campus wherein we are offering vocational and vocational programs. And we have, I think Professor Shivu John missed this, but he was one of the pioneers in establishing the off campus at Kannur, Kerala. I think you missed that, sir. So we have a branch at Kannur, Kerala as well. And we have a upcoming center at Moradabad, especially focused for the vocational courses. And again, another vocational courses we are trying to bring in the campus as well. That is in the pipeline. So the focus of the university is to skill India, to bring in diversified courses, and to focus on interdisciplinary research. And in that context, we have inter-school associations in terms of we have School of Humanities and Social Sciences, so management people can go for an interdisciplinary research in the School of Health and Social Sciences. In computer sciences, we have, like sir told, we have got around 11 schools and a strength of around 9,000 students, and foreign students from around 27 countries. So, and majorly most of the states in India, I think most of the states in India is represented through its students in our campus. So we have got a very diverse student base as well. Teachers are also from different states. So, and one of the remarkable things about Jamia Hamdard is that we have got a very balanced female to male ratio. So in administration as well, 4 deans of schools are females, although at this point in time, that is a point that should be foregone. People should accept female leadership, but Jamia Hamdard believes in leading by example. So these are the additional points to what Professor Shibujan had told. And I am very, very thankful to all the participants who have joined this program, and especially the luminaries, the experts who could make a virtual presence here. Sir, we extend a very warm welcome to you to join us at your convenience and come to the Jamia Hamdard campus, and we'll be very, very happy to extend our hospitality to you all. And I hope we have a very nice session. First, the head of the department for facilitating and motivating the two young people here. Thank you so much, sir. Congratulations. And to Dr. Jamshed and Dr. Asad, I hope you carry on the good work regularly. Thank you so much.
Okay, thank you. Thank you, Dr. Asad. Congratulations for a wonderful FDP. And I'm very delighted to be part of this great program as an observer from AICTE. If you allow me to share, I would like to share a few slides with focus on research, why, what, and how. So kindly give me the platform. Okay, it's coming up. And all the dignitaries and dear participants, it's my pleasure to be with all of you. I'm going to talk very briefly in my next 5 to 6 minutes remarks about research, why, what, and how. And I think we need to understand the importance of research. This is where India can do better. And the country's sustainable growth and competitiveness depends on research, both basic and applied. If we look at all the rankings, starting with the Ministry of Education, NIRF score ranking, research is one of the components which counts for 30%. And it's looking for publications volume, publications quality, and patents granted. If we go at the world level, Times Higher Education World University Ranking, research is again 30%, and citations are another 30%. So combined research and citation is 60%. And not a single Indian university in top 300 rankings based on the latest results for 2022. And the World University Research Rankings shows that India at the global rank only at the tail end. 3 universities, IIT Bombay, Indian Institute of Science, and IIT Delhi occupy the number 3 out of 240. And if you look at the Science Citation Index and social Can you hear me okay?
Volume increase करो अपनी.
Yes, sir, we can hear you.
Yeah. And let's have everybody else muted so that there is no disturbance, please. Thank you. So Science Citation Index and Social Science Citation Index, India is number 3, China is leading, followed by US. Now, what is research? I'm sure all the people who are on the call, who are attending this workshop, they know about it, but the foundation is we want to create some new knowledge and use the existing knowledge in a new and creative way to generate new concepts, methods, and understandings by doing systematic investigation in the study of materials and sources to establish facts and reach new conclusions. And of course, research can be basic, applied, and it can be experimental development as well. Now, here is the most important item, how to do research. All the esteemed resource faculties will go through some of the fundamentals on the qualitative and quantitative side of research methodology. But the sincere request is faculties who are good at research, they need to excite, engage, and empower all the students at various levels, the undergrad, the grad, and the postgraduates, to show them how to do research by spending time with them, coaching them, and empowering them. And essentially, faculties can encourage the creativity, the curiosity, and innovativeness through research. Now, I've not seen a full curriculum at most of the universities, but if we really want to focus on research, some of these courses should be part of the curriculum, starting with the research methods, data management using statistics, ethical decision making, big focus on communication, effective writing and presentation, time management. Now, when you do research, something unknown, project management foundation will be very helpful. And when you are doing a project, something unknown, so risk management is part of the project management discipline. So this robust curriculum should help prepare the students and the faculties to do well and do great research to bring India at the forefront. So here comes the success for the research made in India. Bharat Biotech's Covaxin got the emergency use authorization by World Health Organization for COVID-19. And this is a great example of Atmanirbhar Bharat. With that, I want to stop sharing my presentation. And once again, congratulations, Dr. Jamshed, Dr. Asad, and all the dignitaries. And it's my delight to be joining for the first session to understand the first speaker, and review the proceedings. So thank you very much.
Thank you, Dr. Asad, for a very extensive kind of introduction. Let me thank the Jamia Hamdard for inviting me to this important program. Let me also congratulate Jamia Hamdard for organizing an excellent FDP, a very important area of structural equation modeling and artificial neural network in management research. Very rightly mentioned by Dr. Manu Vora regarding that India is not able to make the mark in the top universities in the world. Also, we rightly mentioned about top 3 researchers in the world right now, China, USA, and India. This shows that now the entire journey will depend on the research, because the way market is changing, we have to do innovations. If you see the current challenges that we used to have a change in 10 years earlier, any breakthrough will come in 10 years. But see, right now, every 3 months changes are happening. So this shows that unless until we are in tune to the industry, in tune to the market development and changes, we have to keep pace with the time. And only research will be able to drive the journey ahead. And then universities have to play a strong role. If you see difference in a college and a school, university means research. But sorry to say that if you see the current developments, all breakthroughs are coming from industry, R&D. It should come from university. If you see earlier, all breakthroughs came from the university laboratories. If you see any breakthrough, if you see the foreign universities, European countries, their laboratories are very, very efficient, and any breakthrough will come from the university system. But we see Indian scenario, what is happening, we are mostly doing research for academic purposes. We want promotion, we want no kind of a position in the university, we will do some research. We know that if you don't do research, we will not get promotion to professor or not get job in the university system. So our approach for research is for academic purposes. We are not doing research as a kind of passion or a kind of innovation and creativity. So we have to change the entire culture. This process, this program is very important because it's going to ignite a lot of mind, inspire a lot of mind to start doing research as a passion, trying to solve a problem. Because see, what happens generally in the current scenario, what happens generally, if you see the universities, mostly in the low private universities or universities in the rural areas, what is happening, they're just repeating something already research happened, because the main problem is survey of literature. So they are not able to have the latest material where you can then find out where is to start. Because if you go on reinventing, recycling the old research, you are not going to add any value. So the question is that how these small universities, in the rural universities, they are able to get the latest material, latest kind of databases. So they will be able to understand that where is the cutting edge and where to start. In this process, I think professors, universities can play a very strong role to at least control the research process, control the quality of the research. And then if you are able to maintain the quality of the research, I think we can lead the world. If you see the databases, if you see the kind of the history, patent per million patent, because what I feel that I'm being the person from the IPR background, one of the parameters is to test the how many patent per million is there. If you see the current scenario, if you see the patent per million, Japan is having around 900 patents per million. If you see America, it is 289. And India is just 34.5. So one Indian person is, if you see, one Japanese person is 30 times efficient than one Indian person. One American is 10 times efficient than one Indian person. It means that every Indian researcher should be more efficient and try to focus on the quality. The way market is changing, we have seen in the pandemic what happened. Around 70% universities could not do any work in the last 2 years because they were struggling to have the kind of IT network, online journals, remote access softwares, and even the faculty were not trained. Students were not trained how to utilize this particular technology for imparting education. Still, we feel that this technology cannot be suited for the education sector. No, I am speaking from 1995 because my PhD is from cyber law, and we have seen that we are still lagging behind because there are a lot of activities of the system can be taken over by the AI, by blockchain technology, by remote access softwares. Okay, why we are utilizing our faculty in the clerical job where there is no value addition? They are wasting their very, very kind of the time that can be used for the research purposes. But we are engaging the faculty in all non-productive works, and we expect some breakthrough in the laboratory. How it is possible? Unless faculty should be given proper time, proper technology, online journals, latest technology, they should be engaged in quality research. And all these non-productive work can be given to the software, to the AI, to the computer. Let them do all calculations, examination, preparations, analysis, and all. And then we are able to get some quality research. So I must thank the Jamia Hamdard Department of Management, focusing on a very important area, that is structural equation modeling and artificial neural network. Because now current debate is going on that how we can just see the way a brain is working and how brain is managing entire body. And same thing we can also utilize in the normal scenario. Just like we are seeing about the AI and machine learning. Currently, the machine learning can changing the entire world, because we are going to use a lot of AI for the breakthroughs, for the research work. And now the entire debate is databases. So all the people are fighting for database. Now we see earlier that we used to say anybody who has lot of iron ore, then we said anybody has a lot of gasoline, petroleum will be the market leader. But now the market is changed. Now what we are saying, anybody who has databases will be the market leader. And what we have seen last year when the China was fighting with India in the border, India has gone ahead and just closed 200 applications of China. You can ask question, how closing application relevant to the fight on the border? Yes, because these 200 applications were used by us without having any security system, our privacy violated, and this data can be used by American, Chinese government against Indian interests. So now the entire debate is data. Now how to hold the data, how to capture data, how to analyze data, and then how to get the proper results. So the use of this artificial neural networks, or use of the, because it's a branch of AI, and AI, then we have the machine learning. So the machine learning will depend on how we are going to train the computers, robotics, quantum computing. So my point is that the way technology is going to affect, whether it is a kind of science and technology, whether management education or law education, we have to see that how the integration happening and how the science and technology is going to affect the entire process, and how we can use technology for research purposes. When I can remember my days during the 1995, when I was starting research in cyber law, I traveled entire country to get data. I got hardly 3 books in the entire country because there was no material available on the latest areas of the cyber law and cyber crime, cyber security. But right now, thanks to the technology, no need to go anywhere. You just sit on your computer, you have latest softwares, you have latest remote access software, you have latest technology. You can collect data. You can utilize AI for filtering data. We used to go to library and we have to get physical copy of AIR. We have to get Xerox and go read and find out a case. And it was taking too much time to find out what is the value addition in the case. The case of Kesavan Bharti, it is 1100 pages. If anybody want to know what is the importance of this case, he has to read 1100 pages. But thanks to AI, right now, by application of AI, you can filter out these pages in few seconds, and you can find out the on dotted lines what is the importance of this case, what was the logic given by different judges, and what is relevant to you. If you cite this case in your own case, how it is going to affect judgment, how it is going to change the mind of the judge. It can know the pulse of the judge. So my point is that we have to be very efficient in utilizing technology for research purposes. We can save a lot of time, and then we can use faculty for doing quality research by providing support. And then we have to use the latest things coming in the pipeline, that is the quantum computing. And then we have the 5G technology. With the 5G technology, the data will flow very fast, the speed will be very fast with the quantum computing, and with the kind of the AI, machine learning, with the autonomous cars and all, entire market is changing. My point was that within 3 months time, when everything is changing, why we are having the data that is very old, that is irrelevant, and then it cannot be basis for the further research. So I am focusing that let us have the latest databases, latest technology, support the faculty, support the student, so we will be able to have some kind of outcome that is relevant for future. With these few words, I must congratulate the Hamdard University for organizing very important program and also inviting me for this session. Thank you all of you.
Yeah, thank you, Mr. Abdullah, introducing me. I'm thankful to Jamia Hamdard for inviting me just to share my thoughts about research, what is going on in India. Uh, Professor Vora, Professor Ahmed, Professor John, Professor Haq, and Madam Nasreen. Professor Vora has clearly set a task what India has to do and where we lack in terms of ranking. Lot many things Professor Tabrij talked about, how data is important for the research and how the new technology like the artificial intelligence and machine learning should be used in our research and how to be the latest in terms of the data, in terms of the methodology. But you see, the major problem which I see as a professor, hardly there is any program where we really train people for scientific research. We do some kinds of FDP, 3 days FDP like you are doing here. You make aware, but hardly if you see in our management education, we definitely bring a total focus and on research methodology and how to do business research. But competent researcher is the major problem in India, and not having any design of the course, how to do research, that is the major problem. And another problem is that the people who come to research, so their commitment and their perseverance, that we somehow we do not able to motivate them in terms of finances, in terms of providing facilities, like Professor Ahmed pointed out during COVID situation, how people lack the competence using this whole online education and use of the resources available, online resources available. Yes, we have a lot of resources available here. The only thing is that we have to somehow sensitize our universities that the research is not for the promotion, which he rightly said that. But you see, if you go through the past history of this Indian research, just 5 years ago, how many research the journals have come out? They receive your paper and this published in a one day. And so how is there any body to control such kind of research journals? How we are going to stop the plagiarism? This is and how easily now you see, if I see my inbox, I get to get review the papers on any day, 10-15 papers, and I'm unable to do that. So peer reviewer of your research is a very peer review is a very important, and competent people are not available in India. And if you send it to somewhere outside India, hardly people look at your research. And when my work is not peer reviewed properly, if people are not giving attention to my work, and research is poorly designed, because of the poorly designed, maybe lot of many things, improvement is required in terms of the lab facility, in terms of the finances, in terms of the you see the commitment and the perseverance of the research worker. Indians are really very hardworking. Uh, uh, Professor Tarvej gave you the idea about that Japanese and the Indians. When I visit Japan, if you see in the Japan how Indians are working, in the same lab, Indians are producing much better work. But here the only thing is that how to now the Professor Vora is there, and he has cited so many programs of the government and the AICTE. The problem is that how to sensitize our the whole system, and to make our people understand that research is done only with commitment and perseverance, and it is not for any financial gain or taking promotions. It is they have to pursue for the knowledge. So innovation comes only if you have the perseverance and the commitment to the research. Thank you very much for inviting me. And already so many things about the research which Professor Vora and Ahmed said. Only one more thing which I want to tell you, that in the past, if you analyze the research papers in the area of the business and the economics, there was no fast computing, there was no resources to your store the data. Now these two problems have been solved. Now the data storage is not a problem. Fast computing, like the quantum computing, as Professor Ahmed said, is not a problem these days. And now the only thing is that you have to design certain programs for the scientific training to do research. So this is the only thing which I can recommend here. And thank you very much for inviting.
It was a pleasure virtually interacting with all of you, sir. We do hope you accept our extended invite and come to the Jamia Hamdard campus. Dr. Vora, Professor Tabriz Ahmed, and Professor Sana. Thank you so much.
Thank you, Dr. Reshma, for invitation. It will be pleasure to come to the campus. Thank you.
Please, thank you so much.
All of you. Thank you very much.
Thank you. Dr. Asad, I'll take your leave. Okay. Assalamu alaikum, Sufyan sir.
जी जी वालेकुम अस्सलाम। Assalamu alaikum. Good morning. Thank you very much for giving me this opportunity. So I would like to begin by sharing my slides. So if you can kindly unshare so that I could share. So let me just so can you see my screen? But it is the same screen, right?
Not yet, sir. Not yet.
Google Meet screen. So I believe yeah. Now is it visible?
Not to me.
Really?
Yes, sir. Or else you WhatsApp that the thing to me. I will present from my end.
No, I'll do it so that I can control it as well, right? Is it available now?
No, sir.
No, it should be there.
No, sir.
Just hold on. Yeah, how about now?
Yes, sir. Yes, sir.
And
It's-
can you see it in the
yes,
full
sir.
screen mode?
Yes, sir. Yes, sir. Better. Best.
Okay. So we'll start the first session for this ATAL FDP. And I think I'm privileged in that sense that I've been given the opportunity to address the audience and the participants in the very first lecture, which is on basic tenets of research. So I'll be starting with something very basic and very, very common as well. But then there are a few things that we miss and we assume that they are too common to give a thought to it. So let me begin by enumerating the steps in research. Obviously, any good research starts with a good literature survey. How to do a literature survey, I'll come to that. I'll take all these points in detail. And emerging from that literature survey should be the problem. And we have to define the problem in a proper way so that we can go about looking for tools for solution. And then once we have narrowed down onto the proper tools for solution, we have to obtain the results, we have to present them, we have to publish them, and we have to consolidate and carry out the enhancements and move on in research. So these are the steps that we have to follow in this very order. So let me take these steps one by one and try to give my thoughts on them. So first and the foremost, we have to look at the literature survey. Read as many papers as possible. Don't think that this paper is not very closely related, because interdisciplinary research is the easiest one and arguably the most beneficial one, because it gives you a lot of ideas that you can borrow from one domain into the other, and the results are quite often very encouraging. So you have to read as many papers as possible, because broader the base, higher the building. If you have got a broader base of your literature survey, the building of research that you can take will be having a bigger height. So read even the papers that seem remotely related, and make a habit of reading research papers, just as we read the most interesting novels. All the good researchers, they are into the habit of reading those research papers on a regular basis, to the extent that you may even keep aside a research paper every day for your bedtime reading too. There were those good times when we used to read a book and fall asleep. Unfortunately, our cell phones have taken that luxury away. And that, in fact, I quite often say that this also is turning out to be one of the reasons for the sleeplessness. Previously, when we used to read the books, we used to fall asleep. But today, by gazing at our cell phones, we are driving our sleep off and driving it away. So make a habit of reading books, and better still, make a habit of reading research papers before we fall asleep on our beds. Literature survey should identify some of the key papers of the area from high quality journals. Why I'm saying high quality journals? Because low quality journal papers will leave our research base that much weaker. So try to focus on only the high quality journal papers, so that our research is on a sound foundation, is on a healthy foundation. It is always helpful to read a survey paper if there is one available in that area. Read the papers referenced in the key papers, the references of the references, and so on. So this way, start with one or two key papers, read their references and references of the references, and this way you will be able to develop a database of research papers in your area of research, which you can refer to very often. Now, obviously, reading a research paper means understanding it well. How do you understand a research paper? Because that is a high quality research, and particularly if I'm an alien to that research domain, it will be very difficult for me to understand it, and it will be impossible. Let me use impossible. I'm not using almost impossible. I'm saying impossible to understand a good research paper in one go. That is impossible. Several iterations of reading the same paper will have to be done. So first, you give a rapid reading to your research paper. A rapid reading. You may not get every inch of it or every line of it. Give it a rapid reading. In the first iteration, you will at least have the organization of the paper registered in your memory. Then start all over again. The second time around, you will start making some sense out of that research paper. It will be the third time or the fourth iteration that you will actually have to sit down with a pen and a paper to work through the research paper. The best understanding takes place when you prepare to present the paper in front of some audience. So try to make your own notes, either on PPT or on pen and paper. Make your own notes. carry out all the derivations that are there. If there are any algorithms, make a dry run of those algorithms to understand the paper fully. So it will be 3, 4, 5, 6 iterations that we will have to take before we are able to understand a research paper fully. And do make notes in such a way that you, with the assumption that you're going to present this paper in front of an audience. So that will make you understand that paper better. Write a good survey paper at the end of your literature survey. People do get recognized with their survey papers. So when you're preparing to write a survey paper, obviously you will have to digest all the papers in that particular area before you can come up with the survey paper. So this writing a survey paper will provide you with a couple of things. A good background understanding, because a lack of it will not let you write a survey paper. And once your survey paper gets accepted, you have that extra confidence to work in that area, because you know that you are pretty well versed and you have published a survey paper in that area. So you're very well prepared to launch yourself into the research of that area. So that way, writing a survey paper is very helpful. Now, how do you write a survey paper? Obviously, it should not be copy-paste. The issue of plagiarism will come in. And also, it's not a good practice even otherwise. Try to understand the whole collection of papers thoroughly. Over here, let me bring out one of the jokes that we used to hear when we were young. But let us take a lesson out of it today. You must have heard that this man walked into a sweet shop and he said, "Do you have a bucket?" He said, "Yes, I do have a bucket, but why do you need a bucket from a sweet shop?" He said, "Just bring one." So when the bucket was brought, he said, "Put 1 kg of barfi in it. And then put 1 kg of jalebi in it. And put 1 kg of balushahi in it. And put 1 kg of, every sweet that was available in that shop." He made that shopkeeper put 1 kg of all those sweets into that bucket. And then he said, "Ghoto, make a well mixed paste of this mixture of the collection of sweets." And after that, he said that, "Give me a half of a kg from this." Right? Obviously, that shopkeeper will get very irritated. But with that joke, I want to tell you that proper well-mixed paste should be your survey paper. That half kg is your survey paper. So write down the combined view of that collection. It should not be like reference 1 says this, reference 2 says this, reference n says this. No, it has to be a proper well-mixed paste. Prepare a well-mixed paste, just as I have narrated in the case of that joke, so that you have got the taste of all the papers therein in your survey paper. Form your own categories of the collection. Present a comparative view, preferably in a tabular form, so that it gets written into the memories of the people, of the readers. So bring out the pluses and minuses of the work done so far, with more focus on the shortfalls of the existing work. Why? Because this is going to give you to the significant leads to future directions. So you may talk about the plus points of all the research papers that you have discussed, but give an extra attention to the shortfalls, because they are going to lead to future directions. So do provide the significant leads to future directions. And let me take the liberty of saying a survey paper is useless otherwise. If you're not giving good leads to future directions, a survey paper is just useless. It should lead to future directions. So that should be the aim of a survey paper. So that was briefly about the first step, literature survey. So let me talk about the problem definition now. Once that literature survey is thoroughly done and you have identified the shortfalls of the existing work, to choose on a problem or to narrow down on a problem should be easier. I don't say it will be very easy, but it will get comparatively easier, because you have done a literature survey well and you have been looking or having a critical view on the existing literature. So now, how do we choose a problem for our research emerging out of that literature survey? This is obviously the most crucial step because your research rests on the problem that you have chosen for yourself. Now, there are two ways to go about it. The human tendency is to look for the easiest possible problem. That is the human tendency. We try to go for the easiest problem. But there is a big flaw in that approach, because then you would be expected to give the best solution to it. On the contrary, if we choose a difficult problem, we may get away with any reasonable solution. Let me give you an example. Suppose there is this athlete who wants to take a high jump, right? He wants to take a high jump. Now, there are two ways to go about it. If he is given a choice to set the hurdle for himself, and he says that I'll set a hurdle which is 2 feet high, 2 feet high. Now, everybody will be looking at each and every step of that athlete because the hurdle in itself is not very challenging. So everybody will be looking at his takeoff, at his rhythm, at his poise, at his landing. Everything will be minutely watched. But if suppose on the contrary, the athlete says that I'll cross a 10 feet hurdle. Now nobody cares as to what his every step is like. Everybody is now glued to the bar itself because the bar is too high. And if the athlete somehow crosses the bar, no matter how he takes off or how he lands or how had been his rhythm and so on, he'll still get accolades because he has been able to cross the bar. In some cases, even if the bar is not crossed, the two or something touch, some body part touch the hurdle and it falls down, even then he'll get claps because he had set himself a challenging task, a challenging hurdle for himself. So it helps to choose a slightly difficult problem. As I gave the example, it is like choosing between crossing a 2 feet hurdle or a 10 feet one. With a 2 feet hurdle, you must show rhythm, poise, speed, grace, style, takeoff, landing, and everything. Because in the hurdle itself, there is not much challenge. But in the case of a 10 feet high hurdle, if you just cross it somehow, you are done. So likewise, in research, we have to choose a difficult problem. But a word of caution, do not break your legs by choosing to cross a 100 feet hurdle either. Do not choose too difficult a problem. Choose a problem which you can stretch yourself and achieve. Right? There are two kinds of problems. One is a closed problem and the other is an open problem. Right? For a closed problem, we all know that there is a solution. We have to find a solution. An open problem is the one that we are not even sure whether a solution exists or not. And we're still searching in the dark for the solution. So this closed problem may be taken up as a bachelor's project or as a master's project, but certainly for a PhD or a doctoral or a postdoctoral research or beyond, we have to concentrate on open problems, open challenges from the research domain. Let me bring out this interesting quote that was written at the office door of Professor Lotfi Ezadeh. He was a professor emeritus at the University of California at Berkeley, USA, and he was the father of fuzzy logic. And he was the recipient of IEEE Medal of Honor, which is like the Nobel Prize in engineering. And most importantly, he was my postdoctoral supervisor. So since I'll be touching upon one of the tools of fuzzy logic as the tool for solution, so that is why I gave this short introduction. But over here, I want to bring out this code that was written at his office door. In order to survive here, you have to kill yourself. That is what research is all about. If you have to really survive in the competitive world of carrying out research, we may have to almost kill ourselves, which means we have to set a challenging task for ourselves. We don't actually have to kill ourselves because then all the research will be futile. The idea is that try to put a hurdle or a bar or an aim which is slightly above than what we can easily reach. So that sums up the problem definition. Now I'll have to spend a considerable time on tools for solution. Once the literature survey is done, problem has been defined, we have to look for tools for solution. There are 3 solution approaches, whether you model your problem mathematically or statistically or by some other means. You simulate the solution, but the danger is that you may miss on few parameters. And if those parameters happen to be crucial ones, then obviously the results that you're getting out of the simulation may not be close to the reality and all your effort will be futile. It is the experimentation which is exhaustive, time consuming, but realistic. It may take some extra time and effort, but then it is going to provide you with realistic results. The caution is that you should be able to reproduce the original result no matter how many times you repeat the experimentation. If you repeat the experimentation or someone else repeats the experimentation, he or she should be able to get the same result as you have produced through the... So it should not be a fluke. It should not be a knee-jerk result that you are producing. It should be reproducible. So over here, combine at least modeling and experiment or simulation and experiment, right? You may combine modeling and simulation also, but then you have to take care that all the crucial parameters at least are taken into account. Now, what could be tools for solution? I suggest a shortcut. Just try replicating the existing work. You have done the literature survey, you have identified the key paper. Just try replicating the work reported in the key paper. Once you set about just repeating the same work, you will get ideas for improving that work, because you will be looking at that work from a different angle. Every individual has a different angle to look at things. So you will be looking at it from a different angle. So whenever you get an idea for improvement, try to incorporate those ideas. See whether the result that you produce out of those improvements have improved the existing result also or not. Message kiya, unse ko check karne, WhatsApp check kare. So in that sense, even if you don't get the improvement, even the failed attempts are not futile. And I must remind you, if you have gone through it, and let me tell you if you haven't gone through it, there was this famous English cricketer, Alex Stewart. He writes in his autobiography, we tend to learn more from our defeats rather than from our victories. It is when we get defeated that we sit down with our heads bowed down and we try to introspect, we try to find out the shortfalls or the weaknesses in our approach. When we are victorious, we are overjoyed. We do not care what has gone wrong because we have won anyway. So even if the failed attempts are there, we thought of improving the work, but we ended up in getting poorer results. Let us not lose the hope and the heart. At least we can tell others that they should not take the path we failed in. It makes more sense to get cautious on seeing others stumble rather than stumble and learn ourselves. In this part of the country, the North India, we get severe fogs in winters. It hasn't picked up yet, but when the winters actually set in, we'll get severe fog. And whenever we have to drive in fog, what we do, we always try to keep a vehicle in front of us. It may be a truck, it may be another car, so that whenever the vehicle in the front slows down, we also apply brakes. Whenever there's a speed breaker and the vehicle in front of us stops or slows down, we also slow down. So we can be safe if we have somebody in the front to guide us. And that is why all the VIPs, they have these vehicles in front of them. So let us be that VIP by finding out the attempts that others may have failed in and avoid or take precaution against those failed attempts. So even in some cases, suppose you tried 5 different techniques, 2 of them had failed, but 3 succeeded. So while reporting the successful approaches, you also report the failed approaches. Do not report the failed approaches alone. Otherwise, people will not get interested in it. So a few failed attempts along with most of the successful attempts may have to be reported in the research paper, so that others should take only the successful path and not the failed path. Now, if you ask me to list the tools for solution, statistical tools are quite often very useful. One of the statistical tool is probability. And let me assure you that if we are able to master probability properly, we can model any problem in the world. So that is why I'm going to give a separate and special attention to the probabilistic tool. And then I'll also look into fuzzy logic and possibly some nature inspired solutions, because we saw the birds flying and we invented aeroplanes. We saw the fishes swimming and we invented ships. Likewise, we have seen generations improving. So people, they devise genetic algorithms, simulated annealing. These are all natural processes which people have roped in to provide solution to the real life problems. Ant colony optimization. You know, these small creature ants, how do they work in tandem to solve bigger problems? Swarm intelligence. You know, smaller wisdoms put together create a group wisdom which you can use for carrying out multi-criteria decision making, which is so crucial in the realms of management. To me, management is all about decision making. So if you have a multi-criteria decision making mastered at your end, you will be a better decision maker, a better manager, a better leader, right? So these are the tools for solution that we have to look into. Statistics, it all begins with mean. Find out the mean value, find out the average value, mean, median, so on. But then if mean was good enough, why did we go for variance? What is the need for variance then? Let me give you a basic example. Suppose I tell you to find out the mean of 2, 3, and 4. You will say that the mean of it is 3. But if I give you data like 1, 3, and 5, still the mean is 3 only. But these two data are different. So how can you differentiate between these two sets of data, even if their mean is coming out to be the same, which is 3? The variance will let you know. The variance will let you know the distribution of data across the mean. And that is very important because it will take into account the entire data. If you talk about the mean alone, it would talk about just the mean value and not the distribution of data. So you won't get any sense of the data except the mean value. Again, let me give you an example. Suppose there are 2 shooters who are taking aims, right? And there is this cross wire that they have to shoot at. One of the shooters, he shot a shot here, he shot a shot here, he shot a shot here, and he shot a shot here. If you take the mean of it, it may be the cross wire. Now there is another shooter who shoots here, who shoots here, who shoots here, and the 4th shot, he shot here. Now if you take the mean again, it is the cross wire. It is the cross wire only. So are both the shooters same or similar? No. This one is a poor shooter because his variance is too large. He's too far. Every single shot is too far away from the mean. And this one is a better shooter because he's shooting more consistently than the second one. So it is the variance which will differentiate between 2 sets of data based on the distribution of data around the mean. Likewise, we may have several statistical tools, and that is why people, they do BSc in statistics, MSc in statistics, and even PhD or postdoc in statistics. It is such a developed area. But obviously, we don't have to get into all the tools. We only have to look into the tools that are of interest to us. Let me give you another interesting example. There is this rank order correlation coefficient. It is basically a measure of closeness of two rankings. This coefficient RS, rank order correlation coefficient, ranges between -1 and 1. When the two rankings are identical, RS is equal to 1. And when one ranking is inverse of each other, then RS is -1. It is again an interesting tool to look at because we come across so many ranking problems. For example, in the sports of gymnastics, there are 5 judges and they are ranking the gymnasts in their own wisdom, in their own way, in their own judgment. So how to come up with a consensus ranking? So this correlation coefficient, rank order correlation coefficient may give a clue to it. How to combine those two rankings. Surprisingly, this is the formula for finding out rank order correlation coefficient, regardless of the number of terms in the ranks. So it basically says RS is equal to 1 minus 6 times summation of the square of distance between the two rankings divided by n, where n is the number of elements in the rank, n square minus 1. Let me give an example. Suppose there is one ranking 1, 5, 2, 6, 4, 7, 3, and there is this another ranking 3, 1, 5, 2, 4, 7, 6. So I find out the distance between them. 1 minus 3 is -2, 5 minus 1 is 4, 2 minus 5 is -3, 6 minus 2 is 4, 4 minus 4 is 0, 7 minus 7 is 0, 3 minus 6 is -3. And I square them. -2 squared 4, 4 squared 16, -3 squared 9, 4 squared 16, 0, 0, -3 squared 9, and we sum them up. This is 54. So it is this 54 that I mean when I say summation di square. So let me just substitute, and there are 7 ranks in it, or 7 values in it, 7 elements in it. So that is why in the denominator I have 7 into 7 square minus 1. And in the numerator I have 6 into the summation of the square of distance between them. And it comes out to be 0.0357. So the point to ponder is that regardless of how many elements I have, the 6 remains constant. This is the beauty of statistics. The 6 remains constant, whether you have 7 ranks, you have 700 ranks, you have 8 million ranks, you have 3 ranks even. Everywhere, the 6 remains constant. Very clearly, if one is exactly the same of the other, so everything will be 0, 0, 0, 0, summation will be 0. So 1 minus 6 times 0 will be 1 minus 0, 1. If they are exactly opposite of each other, you can check for yourself. If there is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the other one is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Find out the distance, square it, put it in the formula, and see that it will come out to be -1. So this was just to emphasize upon the importance of the statistical tool, one of which I have given as an example, rank order correlation coefficient. So as promised, let me try to understand and try to convey the real meaning of probability, because it is an excellent tool for modeling. Any real life problem you can model with probability, provided that you have mastered the art of probability. Now, to begin with, let us understand the real meaning of probability. What is the meaning of probability? Suppose I toss a coin twice. Am I going to get head once and I'm going to get the tail the other time? No. Then what does probability of getting a head is 0.5. Suppose I toss a coin 4 times. Am I going to get the head twice and the tail twice? No. No again. Then what does this 0.5 convey? Because this is a realistic case of misunderstanding. The probability means if you carry out that event with the number of trials tending to infinity, only then you will get that probability value. Right? If you toss the coin infinite times, only then half of the times it will be head and half of the times it will be tail. So that is the concept of probability. In order to understand this concept well, and in order to understand that concept once and forever, let me narrate another joke, because that will let you memorize this concept of probability forever. There was this patient who went to a doctor. The doctor examined him and said that I have a very bad news for you. He said, oh, what is the bad news? The doctor told him that you have to be operated upon, and the chances of survival from this operation is 1 in 100. Now this patient started crying. 1 in 100 is too low a chance, too low a probability. So that means I'll certainly die. The doctor said, wait. I have the good news left still. The good news is that in your case, it is going to be 100% successful operation. The patient got shocked and amazed, and he said, how can you be so sure? The doctor said, because I have performed 99 such operations before, and all of them have died. You are the 100th one, so you'll definitely survive. Is that what probability means? No, that is abusing probability. What does 1 in 100 mean? It means that if infinite such operations are performed across the globe by different surgeons, then 99 of them will die and 1% of them will survive. That is what probability means. In fact, with that particular surgeon, if he had already killed 99 patients in the operations, it is very likely that he'll kill the 100th one as well. So let us not abuse probability. Let us use probability to our advantage. So for that, we have to understand the concept of probability. It is only when the number of trials tend to infinity that you get that value. Otherwise, the entire notion of probability falls flat on its nose. So once you understand probability, you will get a knack of choosing a proper probability distribution for modeling your particular problem. And it must be corroborated with the real data. You cannot be overconfident with the choice of probability distribution ever. You will have to corroborate with the real data whether the probability distribution that you have chosen is a fair one or not. In fact, the time is short. Otherwise, I would have given you a tutorial problem of simulating probability. How do you simulate probability? Or okay, let me quickly and touch upon it. Suppose I ask you to write a computer program or a computer algorithm. If you're not good at coding, let me ask you to write an algorithm or a set of steps in which I have to print A with probability 0.2. I have to print B with probability 0.3. I have to print C with probability 0.4. And I have to print D with probability 0.1. Let us see. The summation should be 1. It is 2 plus 3 is 5 plus 4 is 0.9 and 0.1 is 1. Okay. So my problem is that I have to print A with the probability 0.2, B with the probability 0.3, C with the probability 0.4, and D with the probability 0.1. How do we go about doing it? Had we been in a tutorial session, I would have given you time to attempt solving this. But since we don't have much time left, let me tell you the solution, and I'm sure you will appreciate. What you can do, you can generate a, my solution wants, by the very definition or the explanation of probability that I've given, what I want is that if you write infinite characters out of A, B, C, D, infinite times if you to write these characters, then only 20% of them will be A, 30% of them will be B, 40% will be C, and 10% will be D. How can you do that? generate a random number between 0 and 1. There are ways to generate random numbers. I may not be able to devote time to it as of now. Generate a random number between 0 and 1. If this random number happens to be between 0 and 0.2, write A. If that random number happens to be between 0.2 and 0.5, the difference is 0.3, then you can print B. If it happens to be between 0.5 and 0.9, you can print C. And if it happens to be between 0.9 and 1, you can print D. So that is how you can simulate probability. You can simulate probability this way. So we have to master the art of probability if we have to tackle the real life problems in a realistic way. The next I'm going to study or I'm going to discuss is fuzzy logic, as I said. It started with fuzzy sets by Professor Lotfi Zadeh in 1965. It is a very useful tool and an extremely useful tool when it comes to multi-criteria decision making. I'll come to that. I'll elaborate. Just bear with me for a few minutes. Let me introduce the topic first. It started with fuzzy sets. All of us know set theory. I may write a set. A is equal to A, B, C, D, E. These are the elements of A. So I can very crisply say that small a belongs to the set A, but the set element G does not belong to A. 0, 1. Right? And that is what binary logic or digital computers are based upon. The huge success of digital computers have taken us too deep into the realms of binary logic that we have started losing the sheen of fuzzy logic. So it is the time to revive fuzzy logic. Because the next question I'm going to ask you is, does Mr. X belong to the set of tall people? I tell you the height of Mr. X. Mr. X is 7 feet tall. Does he belong to the set of tall people? You can neither say absolutely yes, nor you can say absolutely no. Because Mr. X may be compared with somebody who is 7'4", who is 7'5", who is 7'2" even. Or Mr. X might be compared with a tall tree, or Mr. X may be compared with a high-rise building. So you cannot be absolutely sure of yes or no. That is where degree of belongingness comes in. Mr. X belongs to the set of tall people to a degree 0.9, to a degree 0.95, to a degree 0.8. It is not about crisp set. It belongs or does not belong. Not like that. In real life, we have degree of belongingness. I gave the example of height. Likewise, intelligence. Can anybody say that Albert Einstein was absolutely intelligent? He may have done a stupid thing at one point of life or the other. Beauty, again, it all matters of degree. Highly subjective, highly perceptive. That is what real life is all about. If you ask me, is today a warm day? I might say that today is a warm day. You may not agree with me, even though you might be sitting just next to me in the same city. So these real life observations, real life parameters, real life physical parameters are matters of degrees and matters of perception. And they are highly subjective. Again, let me bring out a concept. Objective, subjective. As teachers or as students, the only picture we have in mind about being objective and subjective are the questions. Multiple choice questions, true, false, fill in the blanks are all objective. Essay type questions are all subjective. But that is a very narrow definition of objectivity and subjectivity. When I say objective, it means that regardless of whom do you take the answer from or whom do you check the answer with, the answer is going to be the same. True will remain true. False will remain false. Fill in the blank this particular word only. Multiple choice questions, if the answer is C, it will remain C, regardless of who is going to judge or check the answers, as far as the answer is correct. But subjective or essay type questions, the evaluation may vary from person to person. Somebody might give 8 out of 10, somebody might give 8.5, somebody may even go on to give 9 out of 10. So it is varying from person to person. So that subjective and objective question is a special case of objectivity and subjectivity. But then objectivity and subjectivity are all around us. And most of the things, if not all, are subjective in nature. Very few things are objective. Most of the things are objective. Warmness, intelligence, beauty, fairness, truth, they're all matters of perception and matters of degrees and highly subjective. So real life problems may be conveniently solved with fuzzy logic and not binary logic. In order to emphasize further, let me ask you a basic question. Is 5 equal to 5? You will say yes. So truth value of 5 equal to 5 is 1. Very good. Right? Please mute yourself. Please mute yourself. Now, if I ask you another question, is 4 equal to 5? You will say no. So truth value of 4 equal to 5 is 0. If I ask you, is 3 equal to 5? You will still say no. And the truth value of 3 equal to 5 is still 0. So let me argue that isn't 4 equal to 5 is less false than 3 equal to 5. You may start partially agreeing with me. See, partial. This in itself brings the concept of fuzzy logic. And even if you don't agree, you say, no, 4 equal to 5, 3 equal to 5 are equally false. If it is not 5, it is not 5. Let me ask you another question. What about truth value of 4.9999 equal to 5 versus truth value of infinity equal to 5? If I ask you the truth value of 4.9999 is equal to 5, you will still say false with the same authority. You will start thinking that no, I think probably we can make 4.9999 equal to 5. And if I'm comparing it with the truth value of infinity equal to 5, you'll definitely say 4.9999 is much closer to 5 than the truth value of infinity equal to 5. Okay. Likewise, again, let me give another example. Suppose I'm teaching a class of very small kids, small children, and I ask them to spell cat. So the first student stands up and says C-A-T, cat. I said, very good, 10 out of 10. You've absolutely done a marvelous job and a wonderful job. Now I'm asking another kid, what is the spelling of cat? Now this WhatsApp age guy, WhatsApp age kid, he stands up and he says K-A-T, cat. I said, no, wrong, false, 0 out of 10. Okay. I gave a 10 out of 10. I gave a 0 out of 10. Now the third kid stands up and he said the spelling of cat is PQR. What will I do? I'll start banging my head against the wall. Not just that. I'll start rethinking that maybe K-A-T, cat, is a better spelling than PQR being the spelling of cat. Right? So this is the degree of belongingness. I will say that, okay, K-A-T, cat, I may not give 0. I may give something like 7 because at least 2 characters are the same. Or I may even give 8 because K sounds like C. Right? So this is the concept of fuzzy logic, which cannot be painted in just black and white. True, false, yes, no. There could be shades of truth. There could be shades of truth. So this degree of belongingness is the membership value in fuzzy logic. Is the membership value. In the case of crisp membership, the truth value of x equal to 5 will remain 0 all along. Exactly at 5, it will have an impulse of the amplitude 1. It will go through here and it will go again 0 for anything which is not 5. No matter even if it is closer to 5, like 4.9999. But in fuzzy membership, what we will do is that we will have an asymptotic function in which at 5, it will be 1, no doubt. But anything in and around 5 will start gradually decaying. And it will be only at minus infinity or plus infinity that this will touch 0. Anything short of infinity or minus infinity, it will have some finite value. But these asymptotic functions, they are computationally intensive because they require exponential functions. So that is why we approximate them by triangular membership functions, which are linear in nature, triangular membership functions. So there are two straight lines. It may be 1 at 5, all right, but then it starts decaying in a linear fashion rather than in an exponential fashion. So when you go too far away from 5, I might approximate it to 0. But anything in the vicinity of 5 will have some finite value less than 1, but not 0. So that way it is a good compromise. Again, is triangular membership function the only way to go about setting up a membership function? No. I'll give you another example. But before that, let me understand the difference between fuzzy logic and probability. It appears that both are the same. No, they are very much different. And they're not competitive to each other. They are augmentative to each other. Let me give you an example. Suppose I have two glasses. About one glass, I say that membership value of water in this glass is 0.7. For another glass, I say that probability of water in this glass is 0.7. The value is the same. One is the membership value, the other is the probability value. What is the difference between the information about these two glasses? When I say probability of water in this glass is 0.7, let me try the basic definition. Let me apply the basic definition of probability. If you give me infinite such glasses, then 70% of those glasses will have completely water and 30% of those glasses would have something else. This is the concept of probability. In the case of membership value, whether you give me 1 glass, you give me 10 glass, you give me 1,000 glass or billion glasses, all of them, every single glass will have 70% water and 30% something else. So this should make you understand this example should make you understand the difference between probability and fuzzy logic in a clear, in a very crystal clear way, right? Probability of water 0.7 and membership value of water being 0.7. What is the difference? Also, one of the examples I can give, suppose I have to drive from point A to point B. There are two ways to go about it. One is a straight way, which is punctuated with traffic lights, and other is the ring road way. Now, this ring road way is a probabilistic route. If you're starting in such part of the day where the traffic is less, you might go from A to B in half an hour flat. But suppose the traffic is heavy, you might take like an hour and a half or 2 hours by the same route. So this is a probabilistic route. Whereas going from A to B with properly regulated traffic lights, I am assured that I'll be able to move from A to B in 1 hour, regardless of which part of the day I'm moving by, right? So probabilistic route versus fuzzy route. And also the summation of probability has necessarily to be 1, but the summation of the membership values may not be 1. It may be 1, it may be more than 1 as well, right? So not necessarily so. That is a summation being 1 for membership values. Now, this is another example of having a membership function. One of the examples I've taken, triangular membership function. This is trapezoidal membership function. Okay. I can have low, medium, high, or I can have, say, cold, warm, and hot, right? Somewhere from minus infinity to 10 degrees Celsius, I'm granulating it. I'm providing a granule of calling it cold. Now with an overlap from 10 degrees, maybe 8 degrees or something, up till say 30 degrees, I might call it a warm day. And from anything which is above 30, I'll call it a hot day, right? So I'm providing membership values to my perception of heat, to my perception of size, low, medium, high, or whatever. Now, fuzzy logic versus binary logic. Binary logic operates in just 0 and 1. If you are slightly conversant with binary logic, let me give you a 15-second time to read it. Just read this while I take a sip of water. Most of you, I'm sure, would have read there are 10 kinds of people. One who know binary and the other, and now you're shocked. What does it mean? In fact, this means you do not know binary. This is basically two. There are two kinds of people. From the machine will take an input from the camera or things like that on how dirty my clothes are, how soft the linen is, how clean do I want to come out. So I'll be basically telling it in words. My clothes are very dirty. Very dirty is my input in words. I want it reasonably clean. Reasonably clean is my input of the kind of quality output that I want to have. And my linen is extremely soft. So very dirty, reasonably clean, very soft. These are my inputs in words. The fuzzy logic enabled machine will decide based on the membership value as to what should be the wash cycle, what should be the wash timing, and what should be the temperature of water, how much detergent should be added, and so on. So likewise, if we are having fuzzy logic enabled machines around us, it will be easier for us to take decisions through those machines in life. Okay. Likewise, we have genetic algorithms, nature inspired solutions. We have to have an objective function, and we code our solutions in chromosomes, and then we make an initial population, right? We take many such solutions and we form an initial population, and then we do a crossover between those chromosomes. Chromosomes are basically binary coded sequence. So I'll do a crossover. Probabilistically, again, I'll take this part and copy here. I'll take this part and copy here while keeping these two parts intact. So these two with the crossover, I'll get 4 chromosomes now. Then I'll do a survival of the fittest with the objective function. Which one of these 4 are the better performers in terms of the objective function that I've set up? So based on that, I may find out that this is a poor solution. So I'll kill it, survival of the fittest. And suppose this is a poor solution. So a parent remains and a child remains. Then I may do a crossover between these two again to get 4 chromosomes. So one thing is guaranteed, that whatever be the performance in the first iteration, in the second iteration, it may improve, but definitely it may not fall down. So that is one guarantee in genetic algorithms. And more the generations I give to it, better the solution I'll keep getting. So this is the successive refinement that I can achieve in genetic algorithm. I'll give a minute to this very important concept of mutation. Mutation is basically bringing in a surprise part or a surprise feel to the entire thing. What happens? Suppose I'm trying to minimize a function. I was going very smoothly and I was moving towards the absolute minima, but somehow I got caught up in the local minima. Every time I do a crossover, I rise from it and then again I fall back into this local minima. So this mutation gives me the surprise factor. It will flip one bit of my chromosome and I may be able to reach somewhere here, or I may be able to reach somewhere here. As soon as I'm there, now this will start taking me towards the absolute minima again. In real life, you must have heard of those famous stories coming over and over again. The son of a rickshaw puller qualifies IAS. What is that? Mutation. For generations, nobody is educated. And unfortunately, and I would say illegitimately, they are categorized as the, non-intelligent people. But somehow, out of the blue, one of the children of a rickshaw puller qualifies IAS or does something great. It is basically that surprise factor coming from nature. That is mutation. So with this mutation and crossover, you keep repeating the same generation problem, and that is why this is called genetic algorithms, with the assumption that each successive population will improve over the other. If you can recall that novel of Time Machine, you see, there were these two species which revolve in two different directions because their objective functions were different. One of them becoming physically stronger, the other one getting mentally stronger, right? Because the objective functions were different. So based on the objective function, you will keep, evolving over the generations. Likewise, you may have so many other nature-inspired solutions. It may be for complex problems, successive refinement guaranteed. So a considerable time I've given to tools for solution. Let me now move on to obtaining results. First and the foremost, maintain academic honesty. No manipulations, please. You might be able to publish today, but tomorrow it is definitely going to bring you the disgrace. And as I said, must be able to reproduce the original result over and over again. For that, you may have to compare against some benchmarks which are already there. And if there is no benchmark, then you can compare with the existing work. For that, you may request from previous authors or do yourself. You remember I said in the beginning that try replicating the same work. If you have tried replicating the same work, you have the work ready with you. You compare the improvements with the existing work that you have replicated, and you might be able to get an idea as to whether your results are better or not. Presentation. First tool is approximately 1 slide per minute. This is about research presentation, not the classroom teaching or not the FDP that I'm doing today. So don't apply this rule on me. Why I'm saying this? Because the objective is different in both the cases. When you're teaching a class or when you're taking an FDP, the idea is that each and every one should understand the concept. Whereas when you are making a research presentation in a conference, you may not necessarily get it explained or get it clear to everybody. Some of them will understand, some of them will not understand because they're not interested, they are disinterested. So you have to pace up your presentation properly, 1 slide per minute in every research presentation, so that anybody who's to get it should get it, and those who already know it should not get bored. Pace up the slides uniformly. Again, the research presentation, I'm telling you. Do not put too much material on this slide. Otherwise, audience will read instead of listening to you. You should be the focus and not your slide. People should look at you rather than looking at your slides only. Avoid animation in slides. Technical presentations, research presentations should avoid animation. Animations are there when you have to do marketing. Those people, they use animation in order to catch the eyes of the people. Otherwise, animation will catch all the attention. Nobody will listen to you. Use illustrations, graphs, examples, etc. in order to drive your point through. Now, presentation, I briefly touched upon. Let me go on to publication. First and the foremost thing in publication should be that language must be good. Just acceptable is not acceptable, leave alone being poor. And I'll strongly recommend to read this thin book. It is not a thick book. The Elements of Style, 4th edition, 1999 by William Strong Jr., E.B. White. It does wonders to your writing skills and particularly your technical or research writing skills. It tells you the styles which are appealing to people. So proper choice of words, like a native speaker. Let us not use the wrong words. Suppose if I tell somebody, I want a white paper. I have been looking for a blank paper. So blank is the right word. If I say white paper, that means something else. That is a specific term in the jargon of law. White paper is something different. If I have to ask for a blank paper, I must be asking for a blank paper. So that was just to illustrate the proper choice of words. No copy paste unless quoted with reference. If you think that you cannot express it in a better way in any way, then you may do copy paste, quote it, and give a reference. An excellent computer program with poor print statement is useless. Likewise, an excellent research with poor publication is all futile and useless. So we have to learn to communicate. We have to learn to communicate in writing. We have to learn to communicate in speaking. Communication in speaking is easier than communicating in writing, believe me. Whenever I'm providing letters of reference to my students, I rate them higher in verbal communication than in written communication. Your paper must be completely self-explanatory. Remember, you're not there to explain. Don't assume that this they will make out by themselves. You have to be self-explanatory in such a way that your paper should speak for you. You won't be there to speak for your paper. Use illustration, figures, graphs, examples to drive your point through. If people are not able to understand your paper even by taking several iterations, then your paper will not be cited. People will not take your research forward. Quite often the dilemma is whether to go for a conference paper or a journal paper. Obviously better quality in journal publications, but you get a better or a quicker turnaround in conference papers. And you get the feedback from reviewers quickly, and that gives you an idea whether you're going in the right direction or not. So you may send to a conference first, get the reviews or feedback from the people whom you presented the paper in front of in the conference, incorporate those improvements, and then you can communicate to a journal. So that may be a better way to go about publishing your paper. Now, how do you write your paper? Do not repeat unless for better illustration. Because if you do a lot of repetitions, people, they get irritated. Right? There is this top-down approach. The title comes first, followed by the authors, their affiliations, abstract, keywords, introduction with literature review, body in possibly many sections, result, conclusion, discussion, future direction, acknowledgement, if any, references, and appendix, if any. But this is how it is convenient in reading, but not so in writing. This is another key point I want to bring out. This is a convenient way or the sequence for reading a paper. You read the title first, you make some sense out of it. Then you read abstract, you start understanding in a better way. And then you go on to introduction and literature review that gives you the idea of the feel of that area. Then you read the actual research contribution. Then you look at results, you look at conclusion, discussions, future directions, and so on. That is how it is convenient in reading a paper. In writing, what should you do? If I bang my head in coming up with the title first, I'm the most stupid first person. For writing, what I would recommend, use a mixed approach. Somebody might be thinking bottom-up approach, result and conclusion followed by the body and abstract and then title. No. Use a mixed approach instead. Write the main body and the result sections first. Write this part first. This part. Body, result. Just this one. Body and result. Write body and result first. Then you read the first half of the paper and then write down the abstract with more emphasis to the first half. Read down the second half and write down the conclusion with emphasis to the second half. So body and result. Okay. Then read it. This much of it, you put it in abstract. This much of it, you put in conclusion. And then you write the title in the very end, followed by some cosmetic changes, and you are done. So that is a mixed approach for writing a paper, which is found to be more convenient. Now, consolidation and enhancement, the last step. Results obtained must be interpretable. If you produce wonderful results but you're not able to interpret, hardly anybody will get interested. Good research always leads to future ideas. I've seen people saying in the research paper, this is the ultimate approach that I have come up with. If this is the ultimate approach, that is the dead end. Nobody will pursue research in that direction. Your paper will never be cited. You will be doing a dead research if you are proposing an ultimate result, ultimate approach. So good research should always lead to future directions. Future leads should be there, emerging out of your research. And these future directions should be meaningful. Do not give some vague future directions, meaningful future directions. They should not be so trivial that the question arises why you did not do it. If it was so trivial, you could have done it. Make it a future direction which is substantial. Suggest open-ended problems. I told you the difference between open-ended problems and close-ended problems in the beginning. And change areas after every 5 to 7 years, because you've given your best. You get saturated in 5 to 7 years. So change area, go into a new area and try to use your resources and minds in a newer area of research. So that will be my suggestion for carrying out the consolidation and enhancement and future directions. Now, a few words about pursuing PhD. For those who haven't done PhD, it may be very useful. Even for those who have done PhD, it may be useful for supervision of PhD. Pains in getting a PhD degrees are worth it. Even if I were forewarned that I would never be awarded a PhD degree, I would have still gone after it just for the experience that it has given me in return. And it is not true just about the PhD. It is true about every degree. Bachelor's degree is a training. It is not just the knowledge, it is a training. And that is why if you talk to a bachelor's in engineering, his approach will be different from a bachelor's in law, whose approach will be different. Whose approach will be different from a bachelor's in arts, whose approach will be different from a bachelor's in science. Even though all of them are bachelors, but their approaches differ. So a degree is more a training than the knowledge per se. Likewise, a PhD is more of training, the experience that you gain out of it. No reason other than just gaining the experience of it, going for a PhD is still worth it. Even if I'm not given a degree, the very experience that I gain out of doing PhD is worth going for a PhD. PhD is not about doing research. It is about learning how to do research. That is why after PhD, that is not the end of research. That is the beginning of research. Some good universities like University of Oxford, they write on their DPhil degree, which is equivalent to PhD degree, they write, Mr. X is admitted to do research. You are completing your PhD and they're saying you are admitted to do research. You are qualified to do research now. Till now, you were learning how to do research. So PhD is not about doing research. It is about learning how to do research. And my suggestion would be, borrowed from the realms of cricket, if you stay at the crease, the runs would come. That is the tip that the cricketers passed on to the young cricketers. We have to stay at the crease of our PhD. The research breakthroughs will come through. The papers will come through. We have to stay at the crease. You cannot score 4s and 6s on every ball that you face. You cannot score even a single or a double or a triple on every ball that you face. There may be many balls that you may have to defend. But a point of time would come when you get a loose ball and you will score runs. So staying at the crease, the runs would come. Progress in PhD is a highly non-linear function when plotted against time. You may not do 1 hour of research and get this much result, 2 hours double the result, 4 hours 4 times the result. No, not necessarily. On some days you will put in a lot of time, you will get no result. On other days you will do little and you will get wonderful results. So the bottom line is keep patience while remaining focused during your PhD. Do not lose heart. Do not lose mind. Be focused. Keep patience, do not lose heart. Keep focus, do not lose mind. This is about heart and this is about mind. Remain focused with mind and patience, remain focused with your heart. Good practices during PhD, a notebook for each and everything that you do related to your research. Never use loose papers for anything that has anything to do with your research. Make a notebook, just as we make notebook for the class notes. If you had been habitual of writing the class notes on loose papers, those loose papers will fly off. You will lose them. If not before the exams, you'll definitely lose them after the exam, and you won't be able to reference them at some later point in your life. Likewise, for research, make a notebook, write everything there. Those loose papers you are bound to lose. Loose papers means you have to lose, right? You never know when you need that again. Each session with your advisor must also be properly documented. Each and everything that the advisor tells you, note it down. Even the jokes they crack may have something to learn from. So properly document things. Take everything into your stride. For example, nothing worse than your advisor quitting his job midway. There could be pluses in that too even. Try to look for the pluses. Communicate a few research papers by yourself before taking up the next advisor. You can also learn to be on your own then. The expertise the new advisor would be useful for the furtherance of your research. Interpret it as a blessing in disguise. Take everything in your stride. Take everything as a blessing in disguise. Look for pluses in everything that looks bad otherwise, that looks worse otherwise. Okay? Keep writing whatever you do. Don't wait for it to mature before you pick up your pens or the keyboards these days. Keep writing. Writing your thesis would just be a cut and paste job from your own archive. From your own archive, cut and paste is allowed. That will not be plagiarism because this is your own archive. You had been writing every single day what you did on that day. So simply extract from there and put it in your thesis, whatever is useful. Everything written may not be useful. I agree on that. But you will have that much needed writing practice. What people do, they are doing PhD. For 2.5 years, they kept on doing research. They wrote nothing. After 2.5 years, in the last 6 months, they start writing. They have lost the practice of writing over those 2.5 years. It gets very difficult for them to write because they are not into the practice, into the habit of writing. So you will have the much needed writing practice. And when you're not including everything in your thesis, there could be a few things that you can turn into papers after your PhD. So you will get some extra research papers. Also, if you postpone writing before it matures, you're not going to write anything, you may forget finer points. Suppose what I did today, if I record it today, I'll note even the finer points. If I record it after a week, I may miss some finer points. If I record it after a month, I may miss more finer points. I can just recall the major points only. So the intricacies of the research or the finer points of my research, I'll miss upon if I'm not documenting on a daily or on a regular basis. When to say that you are done with your PhD? Number one, when you start telling your advisor what we can do next. If you start telling your advisor, we can do this next, that means you are nearing the completion of your PhD. When you learn how to make 25 hours out of the 24 hours, it means PhD is about learning the time management. If you started learning the time management, you are nearing your PhD. Ironically, the ideas start coming when nearing the conclusion. In the beginning, you are simply devoid of ideas. What to do? What can I do? You're banging your head. And as your progress in PhD picks up, you start getting ideas. Towards the end of it, you have so many ideas. You're full of ideas. But then this is the time to conclude and keep those ideas reserved for your post-PhD work. The rate of generation of novel ideas could also be taken as a measure of the quanta of your PhD work. Practically speaking, try putting your original work in writing. If you're able to get some 3 chapters of 20-22 pages in double space, you are done. But that should be honest. These are purely your own research. Literature review and everything has to be done before that. Chapter 2 may contain literature review, but 3 main chapters of your research, if you can put them without repetition, without using manipulations, then that means you are done for your PhD. The last thing that I will try to bring before I'll take up questions is the analogy for bachelor's, master's, and PhD. I read somewhere that when you study and you realize that you know everything, they give you the bachelor's degree. If you work further and as soon as you realize that you know nothing, they give you the master's degree. If you work further and as soon as you realize that neither you know anything nor does anyone else, they give you a PhD. That is the plain, harsh truth of life. The more you go into the depth of knowledge, the more you realize how deep it is still left. Okay. So when you study and you realize you know everything, they give you bachelor's. When you realize that you know nothing, they give you master's. And when you realize that neither you know anything, nor does anyone else, they give you a PhD. These days we are specializing. There is a very good quote about specialization also. Specialization is knowing more and more about less and less, unless or until you know everything about nothing. That is specialization. You tend to know more and more about less and less unless you know everything about nothing. Okay, so that is the kind of specialization I am talking about. So thank you very much. I'm sorry I had to hurry because I was given lesser time in the beginning, and I can take questions now, please. Thank you for your attention.
Thank you, sir. If possible, please share this PPT with us.
Yeah, I'll email it to the organizers.
Thank you. Thank you very much, sir.
They can
So nice
share
of
it
you.
with the audience, because I don't have the email of everyone. That can be shared later. Right. So are there any more questions, please?
Better, sir. Participants, please ask questions if you have.
Sir, I have a small question, sir.
Yeah.
Sir, first of all, thank you so much, sir, for a very detailed and excellent presentation, sir. You have covered so many topics. Maybe like it is very difficult to know such a large number of topics, sir. Sir, one thing, sir, sir, regarding the empirical research, like the survey-based papers, as you have told that the future research points are the main should be the main points in the paper. So how shall we? What are the ways to know the more and more future research points, sir?
See, the more you learn about the state of the art work, you can look for the shortfalls. You can have a critical eye on the state of the artwork, and that will give you two significant leads in the future directions. Right? You have to have a critical eye in order to get the future leads, and that will also give you your own problem for research.
Right. Thank you, sir. Thank you, sir.
Okay, anything else?
I don't think that they have any questions, sir, because the most of the comments are coming like that. They are involved a lot in this session, and they are getting all the things. The clarity is much higher, and the way you have developed those things, and the kind of the logic you have used in actually the logic is there, because they was intact throughout the session, and we all was enjoying with the small jokes you have made, so that the things will be in our mind, because this session is unforgettable. Obviously, we will we never enjoyed that much. Thanks a lot for giving us a time.
Dr. Jamshed,
Yes,
if you're not getting questions after the lecture, there is either of the two things. Either everybody has understood everything, or they have understood nothing. So, I don't know which category do I fall in.
I think
Anyway,
they can answer the.
It was nice interacting with you all, and looking forward to more such interactions at some other point of time later.
Yes, sir, surely, sir.
Okay.
Actually, giving time to us is really, it's very, beautiful and most, we can say that it is most desired thing for all of us, because being a researcher, interacting with the kind of person who are devoting a lot of thing in the research, and that's the thing which we normally find that Indian people who are doing research and coming from our institutions and so on. So thanks a lot for giving the time, sir.
Okay.
We
I
will
take
begin the next session after some minute. Yes, yes, sir. Thanks a lot, and I just want to thank you to everyone to be patient throughout the session, and we will start from 12 o'clock the next session. Till then, you can take a break. Thanks a lot again, sir. The words cannot,
Signing
give
off.
the right message to convey the thanks from my side. Thanks a lot, sir.
Okay. Thank you very much.
Respected participants, you can chat about your, your small introduction, so that the people can know you, and if they need any help at your place, they can contact you directly. You can write your name, email ID, so that the people will save that according to their own convenience. You guys, I am going to share the feedback form. Thanks a lot. Just give me a minute time. Till the time, you can share your, details, introduce yourself, so that everyone will be aware that with whom we are